Hello and welcome to this video on what is MTMM. My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including structural equation modeling, factor analysis, multi-level analysis, or latent class, latent profile analysis. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional resources, including a link to my free weekly statistics newsletter, as well as courses that I teach for QuantFish. In this video, I will be talking about the MTMM or multi-trait-multi-method approach, and it's going to be rather basic. I'm going to explain where this comes from, what this is about, what we can learn from it, and I'm going to show you an example. And then this also relates to multivariate statistical methods, because oftentimes in more advanced studies, we analyze MTMM data using confirmatory factor analysis models, and you can find videos on that topic here on this channel as well, showing how confirmatory factor analysis can be used to analyze MTMM data. So, what is MTMM and where does this come from? This approach was presented by two gentlemen named Donald Campbell and Donald Fiske in a 1959 Psychological Bulletin article that has become extremely famous and extremely highly cited. The MTMM approach is a very, very influential psychometric measurement-related approach in psychology and other fields. And the MTMM approach is related to the question of construct validation or construct validity. So what is this about? Oftentimes when we create new measures, new tests, new items in psychology or other fields, we want to know about the psychometric properties of these measures. And so one important aspect is reliability. We want to know how precise these measurements are, how much random noise or random measurement error is in the scores, and how much error variance is reflected in the test score variables. And so that is one issue. And then validity is another issue, where we want to know whether the tests or measures that we developed measure what they are supposed to be measuring. So does an IQ test really measure intelligence? Does a depression scale, a self-report scale, for example, really measure depression, or does it measure something else? That's the question of validity. And construct validity is one aspect of validation of measures, and specifically there are two aspects to construct validation: convergent validity and discriminant validity. And you can see here that the title of Campbell and Fiske's 1959 article was Convergent and Discriminant Validation by the MULTITRAIT-MULTIMETHOD Matrix. So obviously MTMM has something to do with construct validity and construct validation, and specifically with finding out about convergent and discriminant validity. So let's first of all clarify what we mean by convergent and discriminant validity, so that we will have an easier time understanding the MTMM approach and the MTMM matrix and what it is about. So what is convergent validity? Convergent validity means that measures of the same construct are expected to show agreement, or more technically speaking, that they should be highly positively correlated. For example, when you measure depression in children by child self-reports, parent reports, and teacher reports, then there should be a substantial correlation between self, parent, and teacher ratings of depression. And ideally, those relationships should be close to 1.0 in terms of a correlation coefficient for the overall scale scores, so that we can see those, so that we could say those measure the same thing. They measure, hopefully, depression. So convergent validity means to say convergent evidence from different methods, different sources, different raters of measuring the same construct, and often that is measured by a correlation coefficient to see whether the ratings that are obtained from one source or method are strongly related to the measurements that are obtained from a different source or method. And we will see that that's exactly one aspect of the MTMM approach that can be examined with an MTMM matrix. Another example would be different intelligence tests. They should be expected to be highly positively correlated. So for example, let's say there is an existing, validated, established IQ test, and you want to develop a short form of that test to be able to administer something that doesn't take as long. And so you develop a short IQ measure and you want to know, does this measure really still measure intelligence? Or does it measure something else? Then you can collect the scores on the original long-form IQ test and the newly developed short-form IQ test, and you would correlate the scores because you have them then from the same people, and then you would expect the correlation to be near 1.0 if the new intelligence test was also valid, and then that would be evidence of convergent validity if the scores on the new test correlated highly with the scores on the already established validated test. What about discriminant validity? Discriminant validity means that measures that are supposed to measure distinct or different constructs should not be too highly correlated. For example, when you have self-ratings of depression, then those should not be too highly correlated with self-ratings of extraversion, because extraversion is a distinct construct. There may be some relationship between depression and extraversion, such that more highly extroverted people tend to be happier, so they would have lower depression scores. So we would expect there to be a maybe moderate negative association between depression and extraversion. However, it shouldn't be a correlation of negative 0.7 or negative 0.8, let's say. Then we would say, wait a minute, is this not also maybe measuring then the opposite of extraversion? If it's negative 0.8 correlated, then that depression scale would be kind of sketchy. So to say, if there was a strong absolute value of the correlation between those two scales, because they should be distinct. There can be a correlation, but it shouldn't be too high. It definitely shouldn't be near 1 or near negative 1. And then what this is about is that when you have a lack of discriminant validity, this may indicate that a new measure is invalid or redundant, in the same way as when it lacks convergent validity. That could also be an indication of invalidity of the measure. So a lack of discriminant validity could also indicate that the new measure is not measuring what it's supposed to measure, because it may just measure the same thing that other scales already reflect, and then it would be redundant and obsolete. So those two aspects are important for construct validation, convergent validity and discriminant validity. And so Campbell and Fiske proposed the MTMM framework to address convergent and discriminant validity in an effective way, and also in an efficient way, by looking at both of them together in a correlation matrix, in a specific type of correlation matrix that is called the MTMM matrix. So let's take a look at the MTMM matrix and what that looks like. Here's an example. And so you can see that here we have 3 different constructs. So multi-trait, multiple constructs or traits, depression, anxiety, and competences. And we also have multiple methods. Method 1 is self-report, method 2 is peer report in this case, and method 3 is parent report of these 3 constructs. So it's a fully crossed 3x3 MTMM design where we have 3 traits that are measured by 3 methods. So we have here a total of 9 different variables that we can correlate in this design, and this leads to a whole bunch of correlations that we can depict in a correlation matrix. So really what this is just a standard Pearson product moment correlation of the scale scores, the test sum scores or questionnaire sum scores from these rating scales. However, the values are arranged in a specific fashion in this design. Other than that, they're just normal correlation coefficients, but they are arranged in a way that they can be interpreted neatly in terms of convergent and discriminant validity, as we will see. So let's take a look at the components of this MTMM matrix. First of all, you may have noticed that there are values in the diagonal of the correlation matrix here that are shown in parentheses. And this is actually something that is, first of all, slightly confusing to many people, because typically really what should be there in the main diagonal of a true correlation matrix are the values of 1.0, because those are the correlations of the variables with themselves, and those are always by definition perfect. When you correlate something with itself, the correlation must be 1.0. Now, since this is boring and uninteresting, Campbell and Fiske proposed putting different values there that are more relevant to a psychometric analysis, and they proposed putting the reliabilities there. So reliability estimates that are obtained from some other analysis. So they're not part of the correlation matrix, they're not coming out when you print in a correlation matrix, but they would be obtained from a separate previous analysis of reliability, for example, by computing Cronbach's alpha, if that's appropriate for the items of the scale, or some other measurement model fitting that results in a viable reliability estimate. And so since these are not correlations, they are put in parentheses to make clear that those are distinct, and they don't have anything to do with validity, neither convergent nor discriminant validity. They just simply give the reliabilities. And it's useful to have that information in there as well, first of all, because we do care about the reliability of the measurements as well. The reliability coefficient gives us the proportion of variance in each scale that is true score variance. So it's an estimate of the proportion of true score variance. For example, this would mean for the depression self-report, 84% of the variance in those scale scores are true score variance, and the remaining 16% are measurement error variance. And so that's useful for us to know in any case. And also it is useful for us to know whether the scales differ strongly in their reliabilities, because if that's the case, then the correlation coefficients in the matrix may be difficult to compare, because we know that correlation coefficients are attenuated by measurement error. So the lower the reliabilities, the more the correlations below the diagonal reflect underestimates of the true score correlations, and that's important for us to know. For example, when a reliability is as low as 0.64, like here for the self-reported competences, that jeopardizes part of the interpretation of those correlations that are found off diagonal, because these are then underestimates when they involve the self-report, which has such low reliabilities. And it might make it difficult for us to compare the different correlation coefficients, which later on we want to do when we analyze an MTMM matrix in detail. So therefore, there's good reason to include those reliabilities in the main diagonal here, so that we can also see how much measurement error is in there and how strongly those correlations may be biased, may be underestimated. So that's the first thing, the reliabilities. Those are the mono trait, mono method values, because mono means the same trait, mono method means the same method. So the correlations of the variables with themselves here are replaced by reliability estimates. Next are the so-called heterotrait mono method values. So those are the correlations of different traits measured by the same method, and we find them in the triangles directly below the main diagonal with the reliabilities. So those are correlations between different traits measured by the same method, and they are about discriminant validity, obviously, because they involve different traits, and so we don't want them to be too high for discriminant validity. Now here you can see that they're relatively substantial, and in fact they are the highest absolute in terms of absolute values. They're the highest values other than the reliabilities in this matrix, indicating that there's not such great discriminant validity here relative to the convergent validity, as we will see later. And this is often indicative of a method bias. So this shows that there's a shared method bias. The correlations within self-report, within peer report, within parent report are more strong because, or are stronger because of so-called halo effects oftentimes, where a certain general impression of a person drives the ratings of all kinds of distinct constructs. So somebody who seems depressed also is rated as anxious, even though that may not be the case, is rated as less competent, even though that may not be the case necessarily. So those halo effects often drive these heterotrait monomethod correlations up, and they're often higher than we like, and they indicate oftentimes a lack of discriminant validity. Next are the subdiagonals below these triangles, and so these subdiagonals are contain the monotrait heteromethod correlations. So mono here meaning again same trait, and then heteromethod meaning different traits. Different methods. So those are the correlations between the same traits measured by different raters. And those are the ones that indicate convergent validity in an MTMM matrix, because they show us how the ratings for the same construct or trait are related across raters. So whether, for example, peer and self-reports agree with regard to depression. You can see the 0.2 here would be the agreement correlation or convergent validity coefficient for the depression self-report compared to the depression peer report, and it's very low, indicating very low convergent validity with regard to depression in this example. For anxiety, it's even lower, 0.12. For competence, it is the highest for self versus peer here, 0.28, but still very low. Remember, those should be 1.0, right? For perfect convergent validity, if those different raters measured the same construct, we would want those correlations to be close to 1. Now, not exactly 1, because we know there's unreliability. We saw that the reliabilities here are not perfect, so a little bit below 1 they could be, even if there were perfect convergent validity at the latent or true score level, but definitely we would want them to be higher than 0.2 or 0.28. So this indicates a lack of convergent validity. There's not great convergent validity here for those different ratings, self and peer, and it doesn't look much better for self versus parent, where they're a little higher, 0.3, 0.23, 0.29. They're a little better than for self versus peers, but still not great. And then also the correlations between peers and parents, 0.34, 0.20, 0.43, they're the strongest, but still they're not really looking so good. Typically, we would want to see something more substantial. That being said, it's also not rare to see a finding like that for constructs that are more about internalizing behavior or internalizing problems such as anxiety and depression. That's harder to observe if somebody is depressed or anxious. The children may just be quiet and it's not really clear how they feel. Do they feel depressed or are they just introverted? And so that being said, so to say, we can then see that there's some reasons for why self and other ratings don't converge so well for those constructs, especially for children, where it might be even harder to figure out how a child feels than how an adult feels. So not great convergent validity, not super great discriminant validity so far, but there's more to an MTMM matrix, and that is the remaining triangles that are grouped around those subdiagonals with the monotrait heteromethod values that we just looked at. And so those triangles that are shown here now are the heterotrait heteromethod values. So again, we are now looking at different traits, but now we're also looking at different methods. So different traits measured by different raters, how are they correlated? And so you could say, well, why should I care? Because those have nothing in common, neither trait nor method, but they're also indicative of discriminant validity because they are heterotrait correlations and they serve as a baseline comparison against which we can, for example, compare the convergent validity coefficients in the monotrait heteromethod subdiagonals. And that's exactly one thing that Campbell and Fiske in their article recommended. And so when we look at that comparison, we can see here, when we just eyeball it, that there's not a huge difference between these heterotrait heteromethod values and the monotrait heteromethod values that indicate convergent validity. And that's bad, because that means that really there's not a clear, distinct advantage or size difference for the monotrait heteromethod values. Those should be much larger. So the values, again, in these subdiagonals here, the convergent validity correlations, they should be much higher than the values in the surrounding triangles where the variables have nothing in common, so to say. And so if that's not the case, if those values here in the subdiagonals are not clearly larger than the ones that are in the triangles surrounding them, then that's indicative of insufficient or not great convergent validity. So this is in essence what an MTMM matrix looks like, what the components are and how they are interpreted. So let me summarize. In the main diagonal of the MTMM matrix, we typically put the reliabilities. Those are the monotrait, monomethod values. Normally we would just have 1.0 there, and since that's boring, we replace this with the reliability. So that gives us a sense for how much measurement error there is in the scores and how high we can expect the correlations to be, given that measurement error attenuates the correlations. Next were the heterotrait monomethod correlations that were found in the triangles right below that reliability main diagonal. Those were indicative of discriminant validity and halo effects, effects of shared method variance within the same method or rater type. And then in the subdiagonals in the matrix, we found the monotrait heteromethod correlations that give us a sense for convergent validity across different methods or raters. And finally, we have the heterotrait heteromethod correlations in the triangles above and below the monotrait heteromethod subdiagonals, and those serve as a baseline condition for comparing the convergent validity coefficients and also as an indicator of discriminant validity. Now, there's not just the MTMM matrix, so to say, and Campbell and Fiske didn't just throw that at people and said, here you go, do this design with multiple traits and multiple methods and then figure out your convergent and discriminant validity. They also provided guidelines, specific guidelines for how to evaluate an MTMM matrix in terms of convergent and discriminant validity. And so I have another video on this channel that you can find linked below in the description, in which I discuss those Campbell and Fiske criteria for evaluating an MTMM matrix in detail. And so then check that out as well to learn more about the MTMM matrix. And also nowadays we typically, because of the measurement error problem or unreliability problem, we do not use the original Campbell and Fiske correlation approach so much, at least not with observed variable correlations, because these are attenuated. When you have unreliable measurements, when you have variables that are not perfectly reliable, and or when the reliability estimates differ strongly between the different components of the MTMM matrix, then the correlations are difficult to interpret, difficult to compare. Some of them may just be low. For example, the convergent validities may just be low because of measurement error, or the discriminant validities may look better than they should because of measurement error, because they are underestimates, and so they are lower than they actually are in terms of the true score variables. And so therefore, nowadays we typically use methods of confirmatory factor analysis which correct for measurement error. So we look at a latent MTMM matrix, and or we look at CFA MTMM models that directly extract trait and method factors, where we can separate variance components due to trait effects, due to method effects. We can look at correlations between different traits. We can look at correlations between different methods. We can link trait and method factors to external variables to find out, for example, why are there method effects, what explains method discrepancies. And so those are more advanced methods that help us address the measurement error problem and other issues that we have with the basic MTMM matrix with observed variables. Nonetheless, the MTMM matrix framework is still very influential. It's a great methodological development by Campbell and Fiske. It's widely used, it's widely accepted now that MTMM designs are critical for evaluating convergent and discriminant validity and for finding out more about method discrepancies and method effects. And so it is still a very, very good paper to read, the Campbell and Fiske 1959 article, and I strongly recommend reading it. I hope you liked this video to learn more about the question of what is MTMM, what is the MTMM matrix, where does it come from, what is it used for. If you did, please subscribe to this channel, hit the like button, leave a comment in the comment section, and don't forget to check out the description for additional resources.